So I think we are done with the kinematics. Yeah. So kinematics and relative motion we were doing, right? Yeah.
Yes, sir. Riverboat.
Yes. The river and all. River, rain man. So I'll give you something, just hint about the rain man. In rain man, the V velocity of rain with respect to man. Why? Because man is going to absorb the rain. The rain will do nothing. Okay, so it will fall the way it is falling. Also, we assume that the raindrops are falling under gravity, but also under the air resistance. So it is not accelerating, it is moving under constant velocity. So every raindrop will have constant velocity. Okay. So it will fall under gravity with constant speed because of the terminal velocity. If you remember the word, if you know the word terminal velocity. Okay. So under gravity, only with air resistance, it will fall with constant speed. But if you start a horizontal wind, then the raindrop will have two velocity, one due to the wind, another due to the gravity and the air resistance together. So it will have two velocity. The V wind will take it right and VR will take it down. And therefore, in the ground frame, it will move something like this VR dash, which will be nothing but the under root of. Okay. Now, no matter how fast or how slow you walk, the man walks. The VR or the VR dash, whether the wind is there or not, that is going to be constant. Okay. So what do we say that the velocity of rain with respect to man is a constant, velocity of rain with respect to ground is a constant parameter, right? So VRM is called velocity of rain with respect to man. What is VR? What?
Graph.
And the VM is how much? So the quantity which is always constant is the man can speed up, slow down, and as this will change, but this will remain constant. I hope this is clear. So the relative appearance of a raindrop will change as you change your own motion, but can we say that the VR will change? Is it correct to say?
No.
And VRM by definition we can write as VR minus VM. So VR is what? And this is the sum of the two is constant. So the vector which we will draw for the VR, that the same vector we can use for any other changes also. Even though the man starts running faster or slower than before, we are not supposed to change the VR vector. Rest we have to manipulate. So rest we have to change. And because it's a sum of two vectors, so this will follow the triangle law. And if you know how to draw triangle law, the idea is clear. Let's say if you know the man, so man will generally move horizontal or maybe inclined. The VRM will be given to you. So imagine if you know VRM, if you know VM, how to get VR? So you will simply draw the two vectors. Okay. So it is the sum of the two. So VM, if I choose VM like this, okay, I'll draw on next page. I don't have space. So let's say a man is walking towards the right, and it is given that the raindrops appear to be moving vertically downward. What does it mean? Appear to be moving means what is given to you? VR or VRM?
VRM.
And if I'm saying it is vertically downward,
Both of them will have the same x velocity.
so the VR must be the line joining the initial and this, right? Because this is the sum of the two is the VR, correct?
Yes, sir.
And definitely if this is theta, so you can say VR cos theta equals to VM. The x component is same. So VR cos theta is VM, that's correct. But you can also say VR sin theta is VRM. See, this is not the idea is by reading the question, can you draw the triangle? Okay. Sometime the VRM is VR minus VM. So you will be knowing these two actually. And this is not given. So this is given. Given means at least in terms of direction. And the VRM is not given. How to plot the graph? So the VR will be given to you, which you don't know how it is. Choose the VR the way you want at some random direction, inclined from vertical. So as a common practice, you must assume in general at some angle, alpha or theta. And let's call VR. Generally, it will be given to you. And we have to add the vector called V M with
Minus.
minus sign. So man is, if I choose the man to be moving towards the right, actually, so my triangle will draw the man left.
Left.
Now there are three possibilities. There are three possibilities. It could be ending here. It could be as big as enough here. Or it could be even bigger than that. So if it is small enough, not big, large, like, so if it is very small, then this is your VRM, which will also make some angle. If it is exactly like this, so that the line joining is exactly vertical, this is VRM. So this is a very common case which will come across. And if it is even bigger, the VRM will turn in the opposite direction. So in this case, there are three possibilities. It could be like this, or like this. It could be vertical, it could be left, it could be right also. So as the VM will grow, as the man velocity, the value will increase, it will shift towards left, and far left. What is the takeaway from this topic? You should know how to draw the triangle. That's it. And if you know how to draw a triangle, you can solve question with ease. So no matter which question you're solving, try to solve using triangle. It is really easy. Okay. But you need to develop this practice of solving through vector, especially the triangle law. And once you practice, it's easy. Okay. So these are like some few diagrams which you can of course solve. Let me give you some question first. Just a minute, I'll share. Okay. I think I have shared with someone. Okay. Let me search. Yes, got it. Okay, I think last lecture I shared some question from Rainman, right? Yes. But anyway, I have shared some easy question. So you have question from 51 to 56, which are very easy. So try to solve in vector. I mean, that's easy.
All the questions you have to do right now, right?
Yes, all the question.
Okay.
All are easy, then I'll give you some other question. Only using triangle. Huh? I think first, second, third must be done, right?
First 5 done.
Okay. Very good. So answer is also given in the next page. You can check there only.
Done.
Very good. All done?
Yes.
Okay. Sharing the solution of question number 54. And 57. Okay, Darsh, you also done?
2 minutes. No, sir. 2 minutes.
What you did? I don't know. X 5 30.
X by 5 is equal to 1 by root 3.
Okay, that is root 3. X by 5 is
X by 5 is equal to 1 by root 3.
okay. So then
Because
X is
at 45 we are given because rain is falling vertically downwards, right?
uh-huh.
And at when he's moving with speed 5, rain appears to be falling at 45. So vertical speed will also be 5.
Yeah, correct.
Actually, I've done it in rough. Wait, I'll send you the solution for 54.
So your answer, so you got the first component 5 by root 3, right?
No, the vertical component is 5, but when the man reduces his speed, it appears to fall at 30, right?
Mhm.
So we need to find the reduced speed of the man. So let's take the reduced speed of man be x.
Mhm.
So x by 5 must be equal to tan 30.
Why X by 5?
X by 5, right?
Okay,
Because
because
vertical velocity we know, right?
no,
That's what we have to do,
rain is
right?
vertical here. Rain is vertical
It is given. Rain is falling vertical with respect to the ground.
with
First
the
line.
ground. Okay. Then it's correct.
Yes.
Okay, and then it is 30 degree later on. So X by 5, okay, fine. Is tan 30. So what is the answer given? 5 by root 3.
Yes, correct.
Okay. And 54?
Sending. Check.
So first is 4, right?
No, the first one is 8 because when the walker is moving with 8 km/h, the velocity of x in the x direction of rain should also be 8. That then only we'll feel that it is falling vertical, right?
Correct, correct,
In the
correct.
next case, when he's moving with 12, we have to assume that rain then he will fill at 4 km/h.
Correct.
Now let's say the y direction be x velocity something. Then we can use tan 30 to get that at x,
Correct, correct.
and then we can use Pythagoras.
Right. So you use 8, later on it is 12, no? So if they're asking the initial value.
So initial value only I did find, right? Because
you
then
find-
4√3 plus 8 square I did see down.
Why did 8 square not 4 square?
Because then they're asking with respect to ground, right?
So with the respect to ground, the
Velocity is 8, right? Of rain.
in the horizontal direction.
Yes.
Good, very good.
Actually,
Yeah,
that
that's
is what
per-
we need to take care of over here.
Yes. Then you can solve the question from the from the last lecture which I shared.
Relative motion one.
Yes, yes.
Actually, I wasn't able to complete that sheet because of boards.
Yeah, that's not an
Just a second.
I think this is mostly not a riverboat problem. This is
No
not,
riverboat problems.
it's not rain man. Rain man, no. There is no rain man here. Do you have any question on rain man?
I think this one is the same sheet you
Yeah,
gave
yeah.
us last time.
Correct, correct. No, no, not this one. The another one below this. On 17th February, I have to just a minute. So mostly we have the riverboat problem. Rainman we have less. There is one question. Okay, so we can go to the riverman problem now. We don't have much left. Okay, any doubt in this sheet? Tell me.
No, sir. I'm just doing the last one.
Yes, sir, just about.
If you've done the rest, then last is also easy only. Only one question is good here. 50, I think 54, 57. The rest are easy only. So river man, a river boat, you can say whatever, river man boat. There are two things which we need to just keep in mind. One is the velocity of a boat or man is the ability to swim, and your ability is defined with respect to the medium. Understood? So for example, if a bird can fly, the ability of the bird to fly is with respect to air, not with respect to ground. Okay. Similarly, if any person or any object which can float or swim or propel itself, in case of steamer and all, the ability is with respect to what? Water itself or liquid itself. So in the river and boat problem, the V we are going to use for what? Velocity of man in which frame? Ground frame or river frame?
River.
So generally, how it is written in the textbook, they will say this is the velocity in with respect to still water. Still water means if you are doing the same exercise in a swimming pool, let's say you can swim at a speed of 1 meter per second, or maybe 3 meter per second, 2 meter per second. I don't know whether you're Michael Phelps or not. So your ability to swim will be always with respect to the water surface. So in case of pool, the entire water is at rest. If the pool is in your colony and somewhere else. But if there is a pool in the cruise, okay, and the cruise is cruising, okay, at 100 miles per hour, the entire pool is also cruising at 100 miles per hour. But your ability to swim across that pool will change or remain same. If let's say the pool length is same as the pool length in your colony, the time taken to cross the pool will remain same or will it change because it's moving? Assume the cruise is moving with constant velocity. There is no acceleration, there is no pseudo force and kind of thing. So what will happen?
It will remain the same.
So does it matter whether the pool is moving or not? Your ability remains same, yes or no?
Yeah, because there's no
So-
relative motion.
Correct. So what is the meaning of a river? A river is a situation in which the surface moves with constant velocity. It can accelerate as well if it is coming from the Himalaya and entering the plain region. But in general, we assume the surface of a river is like a platform which is moving with constant velocity. So you can think as the the floor of the moving train. So the river surface is like the floor of the moving train. So your ability will depend on what? Ability to walk or move will be in which frame? In the frame of the river or in the ground frame? So our ability is always with respect to river, right? The river surface. So you can think the river surface as a moving surface. I mean, a surface moving in one particular direction. And you can always replace the river surface by some sort of infinite floor, which is or like a conveyor belt. Think like a conveyor belt. And that conveyor belt is moving with certain speed. Is this clear what I'm saying?
Yes.
Now your ability to run on the conveyor belt is constant because the belt is moving with constant velocity. So it's a inertial frame. So you won't experience any pseudo force kind of thing. And therefore the ability to run and so do so many things will be same. So imagine if I draw a conveyor belt, so you can think like a river. The width of the conveyor belt is like the width of the river. That's called D. And we do have a shore actually, which is not connected to the river, right? So the shore will be disconnected, right? Because shore will not move, but the river will move, right? And now the conveyor belt starts moving or it is in motion, let's say. So this is called U. The velocity of the what is called U? You can call velocity of flow, reverse velocity, or stream velocity. So you can name it anything. What is V actually? The ability to move with respect to the water surface or the liquid surface or this conveyor belt. Now imagine a person which is not moving, sitting idle on this belt. So there is a observer which is sitting idle. So if you try not to move in the ground frame, you will move with what speed? Same as the conveyor belt.
Yes.
Now imagine a man is trying to cross like this, or is starting swimming like this on this belt, on this river surface. For this guy, he will always walk like this, correct?
Yes.
Why? Because the U will get cancelled. This guy cannot see U. So what he can see? The ability itself. Which means in the river frame, the person velocity in each direction is same. It is always V, right?
Yes.
Because any displacement towards right will be cancelled out by the observer because the observer will shift by the same value, isn't it? So the observer cannot see the displacement along the flow. Now I can replace the observer by the wooden log. Wooden log will float with river, right? So something which is lifeless like a wooden log, any floating object will flow with what speed? U only. So with respect to the floating object, the ability of the person remains constant, right? It is always V. So in which frame the things will change? The answer is in the ground frame here. So this guy will see U and V both, but this guy will see. This guy can see only V, right? So for this observer O2, you can only see V, but for O1 you can see the resultant of U and V. Is this clear?
Yes.
Yes.
Now what O2 will see, what O2 will see is called line of motion. Sorry, line of heading. My bad. So what O2 will see is called line of heading. So in the frame of river, how you want to swim, that is called line of heading. The way you desire to move over the surface. The way you desire to walk over the platform. So what you desire is called line of heading. But what O1 will see, it will not see V or U, it will see something like this, correct? The actual velocity in the ground frame. And this reaction is called what? Line of heading. So line of heading is always defined with respect to ground. And line of heading, sorry, what I'm saying. Line of motion, my bad. Line of motion is always with respect to ground and it represents the actual path of motion. Actual path. But line of heading is not the actual path. It is the path perceived by the O2, by the observer, which is also floating with the same speed. So you need to only understand two things, line of heading and line of motion. So who will decide the path? Heading or motion? The actual path traversed by the person will be line of heading
Motion.
or line of motion.
Line of motion.
So line of motion is the only concept. It is the actual path. Line of heading is the way you intend to swim with respect to surface. So a person may keep on swimming like this always, but if the person will be shifted like this, or you can say drifted like this, it will drift like this. So this is your intention. With this intention, when you reach the other end will not be here, it will be somewhere here, right? So this distance, what we call drift. Now, tell me one thing. To cross the river, you will matter, yes or no?
No.
So to cross the river, you will
Not
not. But of course, how much you travel will matter. So the line of heading will matter, yes or no?
Yes.
Yes.
Because someone is trying to cross the river like this, he has to travel this much. Someone trying to move like this will travel this much only. So in the frame of river, you travel this much only. It is the different story that the river itself is taking you forward. So line of heading will tell you the exact path traced in the frame of ground. Oh, I am meeting again. Oh. Line of heading is the path with respect to the river, and line of motion is the actual path with respect to ground. Okay. So river problem will have only two things: line of heading and line of motion. If you crack these two concepts, it's done. And how we solve question? So you can solve by the way you want. I mean, component method or vector method or mix of both, whatever you find convenient. So in general, make a habit that you assume some axis, a choice of axis. Let's call this as y-axis, this as x-axis. Okay. So this is y-axis, this is the x-axis, and the starting point is origin. The width of the river, let's call d. Okay. If you head in this direction, a really bad choice, but let's say if this is your choice and the choice you're making is making angle theta and the flow direction is towards right. So velocity of man with respect to river is v man minus v river. So what is the actual velocity of man? It is a VR plus VMR. And by convention, this is what we call V vector and this is what we call U vector, if you remember, right? The VMR is known to us in advance. What we don't know is the VM. Because the ability is defined with respect to the medium, not ground. Isn't it? Hello, tell me this clear.
Yes.
Yes, sir.
So the man will have two velocity in ground frame. The V because of the ability and the U because of the medium. And therefore the resultant of the two will decide the actual path. So the arrow of V is representing the line of what? What V is representing?
Heading.
This is heading. So this is the direction in which you intend, you wanted to go, right?
Yeah.
But how actually will go?
V plus U.
Vector wise, right?
Yeah.
And you know how to solve this question like this. Okay. So the actual path will be V dash, or you can say V man. And the V man is, so you can write it as a V man vector as a V vector plus U vector. So if you want to find the V man modulus, you can write as under root of V square plus U square plus 2UV cos theta, right? Very bad way of writing, but you can say V man X equals to U plus V cos theta. V man Y equals to V sin theta, correct? Okay, to cross the river, which component we have to use? X or Y?
Y.
Y.
So, because it's a constant velocity, so we can write Y equals to Uy t and X equals to Uxt. I mean, basically this is Ux. You can just write Uxy. I mean, or whatever. This is just a equation. Don't think this is U. This U is the same as the U which I have used. Make the distinction. So why we can write as a Y component velocity into time, because there is no acceleration. But remember, see, we could have some acceleration. So sometime during the flood, the water may accelerate. Quite possible. So anyway, here things are simple. So Y we can write as Uyt. So the Y displacement will be V sin theta into t. And the X displacement is U plus V cos theta into t. So how much time it will take to cross? So time to cross will be how much? dy. So y becomes d. V sin theta, correct? Isn't it?
Yes.
How
Yes,
much? What is the minimum time to cross the river?
V by V.
In that case, theta must be how much? 90.
Yes.
So the line of heading should be across the river,
Perpendicular to the flow.
correct? But it is a different story. When you reach the other end, you will not be the opposite bank, you will be somewhere else. So maybe you can think this is a local train, the two exit, in local train. So you can exit from this side and that side also. And imagine you're in a very crowded station like Dadar. Okay, those who are not from Mumbai, Dadar is a very famous station in Mumbai. And in Dadar, it is said that if you try to, come out of the gate at Dadar, you will at least go to Parel or Matunga. Okay, if you try there one. So you have to start coming towards the gate at least one station before, right? Anyway. So imagine a person is trying to go from this end to this end of the gate. So what is the minimum time to cross it? How you will walk? So logically, you will only walk across it, right? But when you reach here, the platform will change or remain same. Change. It will change. So that is what is happening. So when you see, you start like this, but when you are reaching here, you are here on a new platform.
Yes, sir.
So we define something called drift. What is drift here?
The
So drift is
horizontal
it is the distance travel along the flow
Along
while
the flow.
crossing the river. So the drift is X value, which is U plus V
Cos theta.
cos theta into D by V sin theta. So this is what you will write in general, right? In general, I'm not saying for minimum value. So for minimum time, for T minimum, theta is 90, as we have seen, right? Correct. So D is how much? Is this clear?
Yes.
Imagine if you want to reach the opposite bank. So how you will travel? So first of all, what is the condition to reach the opposite bank?
Sir, exactly opposite point.
Do you mean?
Exactly opposite. Yeah, I want to go from this shore to that shore. Opposite.
The obtuse
But
angle.
my horizontal component should cancel out the flow. Yeah.
Correct, correct. So your resultant velocity should be like this, right? So this should be what line of heading or line of motion?
Line of motion.
Very good. Because you want to go there, it means this is the line of motion, right? This is the exact path you want to traverse. And for this, there is a condition. You know what is condition? It is only possible when V is bigger than U, right?
Yes.
Because unless V is not bigger than U, you can't cancel, right? Because the component should cancel, isn't it? So to have the resultant like this, what you write is V sin theta is U, right? This is what you write?
Yeah.
And if this is the case, then how much time it will take to cross the river? So time to cross the river is D by,
V cos theta.
and then you know that. And here is the condition, V is more than U, which is required, otherwise sin theta will not be defined, right?
Yeah.
So of course, or you can think this way, the resultant should be like this. Or you can think as the resultant is a right angle to the U, which means U must be a smaller vector. There are many ways of thinking, but anyway. So this is the line of motion. That's the only thing. This is the line of motion. Do this. Here the drift is 0, and this condition is met. Then only it is possible. So to have a 0 drift, this is called the 0 drift condition. 0 drift condition. So the other way of thinking is that if the river is not flowing, in the time t, you will travel like this. But in the same time, the river will take you here, correct?
Yes.
It's the same Pythagoras triangle. And we know how to solve this. So in the time t, you will travel Vt. Let's say there is no flow. But to reach the other end, the flow must take you here. And this is d, so you can write the Pythagoras v square t square equals to u square t square plus d square. And you know the answer. You can always solve like this. Or the x we can write as u minus v sin theta, which is the net x component of velocity, into t. This is how we write the equation, right? And to put x equals to 0 implies what? More mathematical. I mean, you can think the way you want. So to have 0 drift, you are writing everything mathematically, that to have this. Okay. So here time has increased, but the drift has become 0. But this is only possible when v is more than u. So the third case is so we have a river of width. So what happens during flood? The flow is very high. So let's say there is an avalanche in Kedarnath, and there is a flood of water, or maybe the cloud burst. So what if I may say u is more than v? Your ability cannot exceed u. In this case, can we have 0 drift? Is it possible to have 0 drift?
No.
So
Never.
u is bigger. No matter how you draw the v, it is less in this length. Question is how to minimize the drift in this case. Because we cannot have 0 drift, right? Is it possible to have 0 drift first of all?
No.
No.
So we want at least the minimum drift.
So the u minus v sine theta should be minimum.
So minimum drift case, yeah. Tell me.
So u minus v sine theta should be minimum.
U minus V sin theta. Okay.
Theta from the what?
Vertical, yeah, just a minute. So into time is how much?
D by
by?
v cos theta.
So this is the drift in general. I want to minimize it, right? So for X minimum, what we can do?
dx by d theta is 0.
Correct. So you cannot make it 0, but you have to differentiate to minimize it. And once you minimize, you will get the sin theta equals to V
V
by.
by u.
Okay. And then you can substitute back into this equation to get the X minimum. So X minimum is how much? U d by V sec theta minus d tan theta, right? I mean, I just wanted to know. Okay. I think I can write the other way around. U minus V sin theta, which is V by U, and d by V cos theta. What is cos theta?
Under root 1 minus sine.
So this is the minimum drift. You can't avoid. This is the drift you will have. Okay. And how much time it will take to cross the river? D by
D
V
by
cos
v.
theta again. It is fixed. This is the time for minimum drift for X minimum. So in the minimum drift case, this much time you will spend in crossing the river. And still you will land at somewhere here. So you will not land opposite, you will land somewhere here. With X minimum. And now they will give you, let's say you can walk at a speed of V naught. So V naught is the velocity with which you can walk on the shore. So how much time? This is the time. So this is AB. This is AB, right? And this is BC. So what is it? Time to BC? X minimum by V naught, correct? So they will ask you what is the total time? So you can just add AB and BC. Is this clear?
Yes.
Now this
Yes,
this question is having a very nice application of vector, and with vector you can solve with very ease in one line without any differentiation. So only in the difficult question vector is a nice method. As far as question is easy, you can solve by the component and all. So how to think in vector way? Okay. In this case, what is bigger, U or V?
U.
So let me draw U, a bigger U. Okay. And because we have to use a triangle law, so U is much bigger. The V is less than U. So what is the possible direction of V vector? So from the tip of the first vector, I can draw V vector in any direction along the circle. Correct?
Yeah.
So I can draw V like this, like this, like this, like this, like this, like this, like this. But I want to minimize the drift. It means the U and V resultant must be creating the minimum drift, right? I
Yeah.
hope you got the idea. Got the idea?
Yeah.
So for minimum drift, how the V should be? From the U, it should be like tangent to the circle. Because any other direction will have bigger drift, isn't it? Okay, you're not getting this. If I choose V like this, then I will have the resultant like this. This is the line of motion.
Yes.
And this is the smallest line of motion. Do you realize this?
Yes, because V is the smallest.
No, V is fixed. If you take V like this, the line of motion is like this, bigger.
Yes.
And if you take V in this side, it is still bigger. You can check. The smallest is always the tangent. Do you realize this?
It's a limiting case. Yes.
The limiting case. See, if you try to draw the third vector, the resultant of U and V, any other vector will give you bigger line. You can just check manually.
Yes, sir.
So the smallest line is possible only when it is like this, perpendicular. And therefore, this is the line of. If I say this is theta, this is 90 minus theta, this is theta. Okay. No, theta, 19 theta. No, this theta, this is correct. Ah, sorry. I should take the angle from here, right? From vertical, no? From V vertical. If this is theta, this will become 90 theta, this is theta, correct? So what is sin theta? So for minimum drift, the sin theta must be V by U, isn't it?
Yes, sir.
In the right angle triangle, you can see OAB. Hello, hello, hello.
Yeah.
In the right angle triangle, we got directly answer. Sin theta is V by U.
Yes, sir.
So V will be on this circle anywhere. So we have to choose a direction which can give you the minimum drift. And that is only possible if you draw a tangent to the circle. So any line which is not tangent will be bigger than this. Yes or no?
Yes.
Yes, sir.
So everything is done now. So because this is D. Okay. This is how much? This is V, this is U. This is how much? So this is the line of motion, velocity of man. Okay.
Yes.
So in time t, if you cross, so I can say this is VMT lengthwise. This is 90 minus theta. Can you say VMT sin theta equals to D? So time taken to cross is how much? VM. Sin theta. Same answer. Anyway,
Yes.
you can do rest. You can do the way you want, but you can solve everything from vector. Okay. Of course, you can differentiate. Okay. So this is all about the river man problem, but I have given you some good question in that video. Okay. In case of wind and plane problem, what happens? What if we cannot afford? You want to, take off from one airport and land to the other airport. What we cannot afford in case of wind and plane problem?
Drift.
We cannot afford drift. It is not possible to land in the Dharavi instead of or Santa Cruz instead of this airport. Okay, the runway. You can't go left to right. There is no privilege. So drift must be zero. So imagine there are two airports. And with respect to the first airport, the second is located. I will just name it north, south, east, west. So let's say my airport is here. The name of the airport is Bombay. Let's say this is Delhi. So the plane must, take off and land to the B only. Here we cannot achieve, afford drift. So the line of motion is well defined. So the line joining the airport is the line of motion, or must be the line of motion, isn't it? So the line joining the airport must be the line of motion, yes or no?
Yes.
There's no choice. So a line of heading is something which we have to decide. Line of motion is fixed. So imagine the wind is moving this way. This is alpha. How the plane should head to achieve this line of motion? The velocity of plane will be below this line or above this line, this side or this side or this side. Exactly around this line or right of this line
Below.
or left of this line.
Right.
Where? It must be right, isn't it?
Yes. Yeah.
It must be right, and plane is very fast, so I can take a small angle. So this is called the angle of attack. So generally a plane will tilt itself upside down, and then it will attack this air drag, and also it will head in the different direction. So if we know that the wind is like this, we have to head in this different day. In general, the atmospheric turbulence will require continuous change of line of heading. And of course, these all are done through simulation. Of course, you're not trying to do this manually. So you have to be alert enough to keep on changing the line of heading as per the turbulence. Sometimes there's a vertical airflow in certain region of space. And there you see the a bigger turbulence, which is very common. So while going from some airport to some other airport, you will see the vertical turbulence, and they will say, okay, you have to be calm down. Okay, don't worry. So air turbulence is the real thing. Sometimes becomes very dangerous also. In general, in a normal day, the line of heading is kind of constant, but generally they keep on switching because as you travel longer distance, the wind will change its direction. Okay, that is the
And
only
then
talent.
There's some change because of the Earth's rotation also. Like Coriolis force basically.
The
Yeah,
Earth rotation is actually, you see, it will have very less effect because the reason is the flight is not flying very high. And when you fly very close to Earth's surface, so your rotation will be similar to the Earth actually. So your
But like
initial,
if you're traveling from equator towards the pole, then the Earth below you will like move at a slower speed. So you will technically drift. No, like that's what Coriolis force is based
no,
on.
Coriolis force will maintain the path. In order to define the path, that why you're going this way, why you're not leaving the Earth, why Earth is not appearing to be rotating. The plane, the pilot doesn't see the Earth to be rotating, right? Which means the plane is also turning. So how to define that shift? That is defined by the Coriolis force. We say that, okay, there is a force called 2m omega cross v. Okay, so there is a force. And this v is the velocity in the radial direction, like perpendicular to the axis of rotation. And this is the omega of Earth. So let's say Earth is turning this way. If you try to go like this, technically you should land on the different part of Earth, right? the P will come P dash, no? So who is taking you P to P dash? You're trying to move this way, correct?
Hmm.
But you're landing here. So you're actually turning this way. So along with the earth, you're also turning because this force will keep on turning. So this is the explanation we give for the turning effect, like why this plane is turning this way. So it
Sir,
is
but if
turning this way
I'm
because
heading
of
in a
the,
certain direction, like which is towards the pole, then will I land there if I keep heading in that way?
if you head in P direction, you will not land at P. You will land at P dash only.
Okay.
You can't go to the same because see,
Yeah.
when you were on Earth, you had this omega. The medium in which you fly will have omega. So your
Yes.
ability is with respect to medium, not ground.
Okay.
And because the entire atmosphere is turning or rotating, so you are.
Okay.
Your motion is with respect to air, no? Not ground.
Yeah.
You push the air, right? You push the air. That's it.
Okay.
You're applying the Newton's third law, nothing else. Are you doing some magic? No.
No.
So your ability is third law. So air is moving, so you're pushing the moving air. That's it. So air
Yes.
is always turning, and you're pushing that turning air. So your path is actually very complex, but for the distance like a few thousand kilometers, you won't feel much. Yeah, of course, if you travel from pole to equator, that will be a big journey, I think, long journey, but you can travel. Okay, anyway, so here what we can do, this is 90 minus alpha. So because line of motion is well defined, then which component must cancel out each other, if you remember? Whenever the line of motion is well defined, the perpendicular component must be cancelling each other, right?
Yes, yes.
So this is 90 minus alpha, this is alpha, right? And this is, so VP sine theta must be VW cos alpha. Hello. Yes or no?
Yes.
So
Yes.
sine theta is how much? VW cos alpha by VP, that's it. So how much time it will take to reach from it O to B? So D upon VP cos theta plus VW sin alpha. And now we can replace cos theta by 1 minus this bad number, whatever it is. Done. So the line of motion is well defined. You can use it to get the answer. Is this clear?
Yes.
So this is the Riverman problem. There is some problem. Now you can solve any problem which I have shared. We are done with the motion. Okay. Open that sheet which I shared in the last lecture with 3-4 pages. And you can solve question number 17, 18, 19. Or you can solve from a resonance sheet the last ALP question. Have you solved ALP? Just you
So
solve
not all.
ALP. There are 2-3 questions in ALP which are good questions. Yeah. So solve question number which one? 6, yeah. 6 is good. Solve from 1, 2, 4, 4, you can 4 is from your order. 1, 2, 5, 6, 7. Like all LP. You start from like question 1 only. That's better. So idea is clear how to solve question.
Yes.
So I think Kanu has solved already this kinematics, right, Kanu? You have solved this before. So now go to the relative motion. You do have the sheet of relative motion?
Last time which you sent,
Yes, yes. No, I'm asking Kanu. Kanu, you have the sheet? Okay, anyway, I have sent again. So open that, go to LP, solve random 4 5 questions, then we can go to the next topic. Laws of motion. Just 4 5 questions, not more than that. Some random tough question which you think, just take that. Today I'll start the laws of motion also. And I will finish today only. Yeah, any five. Okay.
So,
Yeah. No problem.
sir, in the second question,
Mhm.
the B part,
Mhm.
so we want the vectors to be perpendicular. So, like dot product should be 0. So
Mhm.
behind the same is given, but I just wanted to know whether there was any other method to find out the same.
There are many methods. You can use you
Okay.
can draw triangles,
Sir, draw the triangles only.
and then if it is right angle triangle, then you can do things easily, right?
So I tried using Pythagoras, but
Yeah.
didn't found.
So here is the diagram, I think. Theta from vertical, right?
Yes, sir.
Hmm. So time is going to be simple. No? T will be
To dy to you.
because time is independent of frame, right? So I can choose a river frame.
Ah,
Then okay. So that is easy only. I think VR equals to U only, right?
ah,
Because VR, if I choose this as U vector, this will become minus U vector, right?
yes.
So VR plus U is perpendicular to VR minus U.
So dot should be 0.
Yeah, so that is the best way, I think.
Okay, sir.
Or what else? And that is the best way. I mean, if you try to do other way around, then it will be more tedious only.
Sir, so what could be the other way? Matlab,
To find the perpendicular. So this
Yes.
way, and this way. So this is the resultant. Mm, So this is a theorem actually, if you know this theorem, the angle bisector theorem.
yes, sir.
So if we have two equal vectors, then the bisector, the sum and the difference. So if you bisect this angle and you bisect this angle, this sum will be 90 always, right?
Ah,
So if this is alpha, this is beta, this is a beta.
so alpha plus beta is pi by 2.
So that is only possible when v equals to u. So that's the direct answer.
Oh, okay. Got it. Yes, sir.
But that is like a theorem. Okay.
Ah,
And for that to be true, the values must be bisector. For bisector, it is necessary that the magnitude must be same, right? For bisector, the magnitude must be same, right? V equals to u in modulus.
sir, but sir, it's just bisecting the angle, na. So what is
So,
with
so
the magnitude?
resultant of two vector is bisecting the angle. It means vectors are equal in magnitude.
Acha,
Isn't it?
yes, sir. Yes, sir.
Okay, do the rest. But you all have to solve question number 6 and 7.
Okay.
Oh,
So 6, 7 is like compulsory.
First, then we'll do 6 and 7. Then.
Solve up to 7, 1 to 7. It is not very difficult, just application of ideas. So how many done from the top, Josh?
doing the second one, but then I started the sixth one right now.
No, do it sequence wise. 1, 2, 3, 4.
Okay, just a second. Sixth one, then I'll complete and then I'll do the second one
Okay,
again.
okay.
Ah, ah. So in the sixth one, I'm getting only one set of answers.
In
Sixth one.
Mhm.
Wait, I'll send you a photo.
A man starts swimming at x0. And,
Sir,
Should I send you a photo?
okay.
in the sixth question, the line he always tries to swim in particular fixed direction with the river flow means that he can change his direction in the river flow, right?
No, the line of
No.
heading is fixed.
The line of motion is fixed.
No, line of heading.
Okay.
The direction in which you intend is heading, no?
Ah. No. I'm asking that the line he always tries to swim in particular fixed direction means that like he can change his direction in the river to cancel that component of velocity of river, right?
No. He is keeping his direction constant.
Okay.
And your drift is 0. That's it.
Ah.
So U is changing, na? U is changing. So as you go away, then the U will change.
Sir, so like his magnitude of velocity is fixed, and as time increases, the velocity of river also increases. So he has to adjust his direction with that proportion. No,
No,
that's
no,
what I'm
no,
asking.
no, that is not required. So
Okay,
he is
got
not
it, got it.
maintaining line of motion. It is maintaining the line of heading.
Line of heading. Sir, actually, I was canceling that x component at every instance.
No.
Got it.
So did you see the solution?
Just a moment. Yes. So U equals to 1 T by 2. So A is 1 by 2. That's correct. That is like AX, right?
Ix. So basically, this is like projectile motion only, but instead of G, we are
Hmm.
using A's.
Correct.
Same formula application.
So that is like
So then I
access.
compared the two times.
Mhm.
One will get the
So
48
if
by
you
5
think,
cos
yeah,
theta.
5 was just 5 cos theta, 5 sin theta, and 48 was the width, 48 by 2. Okay, equals to,
5
and
cos theta.
then you have to use the kinematics.
2 into 5 sin theta upon half is equal to T. 2 into 5 sin theta upon acceleration is equal to T.
So you mean to say that, okay, ut equals to half 80 square. So u equals to half 80.
Kind of like that.
So 2u equals to 80.
2u by A.
So 2u equals to 80,
Ha.
so t equals to 2 by 8. Correct.
Yes. That's why. So I'm getting one answer, but they've given two answers. So I'm thinking that somewhere we must also get another answer.
No, the theta will have two. I mean, maybe the
I
trigonometric.
understood what mistake I did.
Hmm.
See, because in that we will get 2 sin theta cos theta, right? So they can be complementary angles.
Correct.
So one we will get 53 degrees also, and for that time period, we will get time period as 16 seconds.
Correct.
Done. Next one.
Hmm.
Hmm.
Then solve the rest. 2, 3, 4, 5. And how to solve the trajectory? Just what is the trajectory of the path?
I'm doing the B part. Hello?
Yes, do it.
Done.
So I'll move to the main concept actually. And this is called velocity of approach. You can also call velocity of separation. So imagine there are two paths. And we have two particles. And at this instant, the separation between them is, let's say, some value r. R is the instantaneous separation. This angle is alpha, this angle is beta. Let's say alpha, beta both are acute. So approach or separation means at what rate the gap is diminishing. So if the gap between two particles is reducing or diminishing with time, we say that they are approaching. And the rate at which the gap is increasing is called the rate of separation. So separation and approach means the reducing gap, diminishing gap, or increasing gap. The gap matters, not the motion. What really matters is the gap. So every velocity can be resolved into two components, one perpendicular to the line joining the particles, V1 sin alpha, and this is V1 cos alpha, correct? And this is also V2 cos beta, another is perpendicular. So now the obvious question is which component can alter the gap and which component cannot alter? Tell me here. So which component we can change the gap between the particles? 1 and 2.
Along the line, like cause of them.
Correct. So it is the component of velocity along the line joining the particles that can affect the separation or approach, correct? But the component which is perpendicular cannot change at all. Yes or no? Yes.
Yes.
So velocity of approach in this case we can write as V1 cos alpha. In this case it is plus V2 cos beta. So velocity of approach is basically the relative velocity in the direction line joining the particles. It is like V relative in the direction. So it is like a find the relative, take the projection in the direction line joining the particle, that is the approach. So vector wise you can say like this. Not required, you can simply use as per the situation. So V approach is the velocity with which you merge the gap. Okay. So in time dt, how much gap will reduce? So the decrement in the gap equals to how much?
V approach D.
So this is the equation which is say that dr integration is V app. So there are some situations when V app is constant in which we can take it out of integration. So if V app remains constant, then we can say that minus dr equals to V app into T. And if the separation goes from L to 0, then you can say that T is always equals to initial separation upon. So this formula is only true when the V app is constant, right? And if V app is not constant, then gap will definitely change, right?
Yes.
Okay. If the same idea we apply for the laws of motion in which we have two blocks connected with a thread, and if we believe that the thread is always taut, so we can say that because the length of the thread cannot increase, the V approach must be 0, correct? Because length of the string is constant. So anything which is connected by the string neither can come closer nor can go far. They must maintain the distance along the length of the string, right? So that becomes the constant relation in laws of motion. That if two points are connected by a thread which is taut all the time, then the constant that length of the thread cannot change will also put the constant that the two particles cannot approach, correct?
Yes.
So that is the same idea which we apply there also. So we just write in a different way. But the idea is that they cannot approach. So if one will try to approach, the other will try to recede or go away in a way that to maintain the overall length of the string. Okay. But anyway, what is the role of the perpendicular component? Any guess? What is the role of the perpendicular component? So if I draw the same line, and if I draw the V1 sin alpha, let's say V1 sin alpha is bigger. What is the role of these values? So role means either V1 sin alpha is bigger or V2 sin beta is bigger. If the upper is bigger, the V1 sin alpha is bigger, the line will turn towards the right, correct?
Yes.
So in time dt, it will turn like this. Like this. And if the separation is r, this is called d theta. So you know what is r d theta? It is the relative motion in the direction, right? So if I fix this particle, this will have two velocities, right? V1 sin alpha minus V2 sin beta, correct?
Yeah.
This we can call as V perpendicular. So can we say this as V perpendicular dt? So it is like the rotation of one particle with respect to other particle, right? Correct?
Yes. Sir.
So when you take the relative of perpendicular, it will give you how much it will turn. So r d theta is always V perpendicular dt. So remember these two terms to solve any question. So we have to remember these two equations. So we can actually find the equation of path of one particle with respect to other particle. So r minus dr is how much? V parallel dt, right? I mean V parallel relative. And what is r d theta? V perpendicular relative dt. And therefore, if I divide these two equations, I can get rid of t. So 2 divided by 1. 1 divided by 2 will give us and in case that these two things are constant, we can have a nice equation. Let's say it goes from r naught to r. And this is called the equation of spiral in case this is constant. So a spiral is basically exponential equation. And r is called the relative separation. And theta is the relative rotation. So we'll come to that. What I'm trying to explain. Okay. So we'll start with the very famous 3 and problem. So we have 3 particles, or 3 and. So every ant will chase the other ant. Now, how we chase? So when we chase, the prey is unaware that it is being chased. So it will move freely, but you will follow. So how we follow? You always aim towards the prey. That's the chase. So chaser will be always aiming towards the object. Okay. So at this instant, if I say the separation as whatever L, so 1 will chase 2, but 2 will chase 3, and 3 will chase 1 back. So the instantaneous direction of 1 will be towards 2, but because 2 is chasing 3, so it will direct like this. But 3 is chasing 1, so it will direct like this. And therefore, after some time, I'll do a simple diagram. The 1 will be ahead somewhere here. The 2 will be somewhere here. And 3 will be somewhere here. So you can do like this. You know what will happen? The entire triangle will tilt a bit. But what will happen to the shape? Because you all have traveled the same distance. If I join the new point, what do you think?
Same equilateral triangle.
It is still equilateral triangle. The shape will not change. So after some time, we preserve the shape. We only change the size. Correct? So this is not the right diagram, but this is the diagram, which is convenient to understand. So if the size will keep on shrinking, eventually where it will meet? Because of symmetricity, where the meeting will occur eventually. At the center of the triangle, right? Centroid. Isn't it? So if you trace the path, you can clearly see the path is spiral. Do you realize this? It will eventually spiral into the center from all direction. All will spiral into same fashion. So do you see this path, the spiral path of each particle? Isn't it?
Yes, sir.
Now here, because let's say if all are chasing with the same speed, what is the velocity of approach of any two particle? What is the approach of any two particle?
Minus the distance between.
V plus V cos 60.
V plus V cos 60, right?
Yes, sir.
Which is 3V by 2. And because this is constant, no matter where you are, at every instant, the approach is same. So the time will be
Minus
how much?
dr by dt.
So they
Two
will meet after this much time. When
Yes.
the separation between them is 0. Okay. At any instant, the separation is reduced. So this will try to approach like this. This will try to go like this. This is 60. So V cos 60 will try to approach, but what is the role of V sin 60? So V sin 60 will turn, right? Isn't it?
Yeah.
So how much it will turn in time dt? So R d theta is how much? Do you realize this?
Yes, sir.
R d theta is V sin 60 into dt. And what is the minus dr? 3V by 2 dt, correct? The reduction in gap is V approach into time. Hello.
Yes.
And because it is always constant, so we can actually create a equation. So 1 divided by 2 or 2 by 1. So minus dr by r d theta is how much? You can see the answer is √3. So dr by r is how much? This is the equation of spiral. So as they will turn, the r will shrink by this relation. Understood? Is this clear?
Yes, sir.
And the other thing is, what is the angular velocity of any particle with respect to the other particle? So omega 2 1. So angular velocity is always V perpendicular relative upon separation, right?
Yes.
V equals to omega r. So V perpendicular, or you can also get from here directly. D theta by dt, which is V sin 60 by r, correct? Same thing, right?
Yes.
D theta by dt is called omega. Okay. So omega 2 1 is √3 V by 2r. So what is the centripetal acceleration of the particle with respect to other particle? So every particle will see that other is turning. So what is the centripetal acceleration? That may be asked. We got omega. So there is a term called centripetal acceleration. Okay, you don't know.
Hello.
Yeah.
I got disconnected.
Yeah. What is centripetal acceleration in circular motion?
Component of acceleration in the radial direction.
V square by
V
r.
square by r.
So formula. Okay.
But here this r is not the separation. This r is the center radius of curvature. So what is misleading here? I have taken the r. You may put the r value which you got. But that R, this R is different, correct? This R is a
Yes.
radius. That R is a separation, correct? So we should use this relation, V omega. So which V and which omega? So this is basically so centripetal is basically V perpendicular omega or V cross omega. So you can get the centripetal as well from here. What is V perpendicular? V sin 60. What is omega? Root 3 V by 2R. So it's the same thing. So omega, and what we need is the acceleration, right? So AC is due to the change of direction, correct? Yeah. How much you have time? V d theta by dt to V omega. So V approach into. Okay, so I think AC, you need to understand what is AC. What is AC? AC is an acceleration which helps in changing the direction, right? So if you turn by angle d theta in a case of circular motion, if your velocity here is, let's say V, I'm taking the speed to 6, and then the speed is still V, but direction is changed. So if I say this as d theta, what is this angle? Angle between these two vectors will be also d theta, right?
Yes.
Okay. So if you draw this two velocity vector as arc of triangle, the change is how much? The dv is v d theta, correct?
Yes.
And therefore the dv by dt is, and this dv by dt is called AC because you are changing the direction, not the magnitude. So d theta by dt, you can see how the velocity vector is changing, and omega. So if you try to apply the same idea here, I know it's difficult. So for any two particles, you can see this is the answer. Okay. And we know that V approach remains same, right?
Yes.
So in any one frame, if I take one as a observer, the two will have two velocity. Correct? So in time dt, it will turn like this. Okay. So the 3v by 2, which is like this, will be like this, but 3v by 2 only. And therefore the the change in velocity, and this is dv, is 3v by 2 into d theta. So this is the change of direction. So if we divide by dt, this is basically our AC, which is 3v by 2 into omega. And omega we know how to write. Or we could have written directly there. R d theta is √3 v by 2 dt. I think this is too much, right? This is omega. Because you can think this way, this line will turn by d theta because of this factor, but this component remains same. So change in velocity vector we can calculate as centripetal. Okay. Okay.
Yes.
Anyway, so this question will, I mean, of course, it should not come, but anyway, you should know how to manipulate things. Okay, what are the applications? They may ask you find the AC or find the acceleration of particle 2 with respect to 1. Find the omega. Okay, so these all questions can come. So we'll come to the another piece of question which is called the Tom and Jerry, rat and cat, whatever. So let's say one of the chaser is like, you know, the object which is being chased is unaware that it is being chased. So it is moving with constant speed and constant, not speed, constant velocity, which is like fixed direction. So let's say the rat is moving with constant speed u. And who is changing? Okay, so this cat is changing. And the initial separation between them is L. How you're going to chase? So in the very beginning, you will point like this. But the very next moment, the rat will come here and will come here. So you will chase in this fashion, correct? Then after some time, you will chase like this. Then like this. Then like this. And this will keep on happening, right? Now, who is traveling more distance, the cat or the rat?
Cat.
So to chase, the first condition is the velocity of cat must be more than you, because in the same time you have to travel more distance to catch. And the line of motion of a rat will not change. Why? Because the rat is unaware that it is being chased. So at some instant, rat is here, cat is here, and this makes an angle with horizontal, let's say theta. So at some random instant, what is the velocity of approach? What is V approach? Yes, this question is this. So tell me, guys, what is V approach? What is the definition of V approach? It is the relative velocity along the line joining the particles.
V minus u cos theta.
Very good. It is V minus u cos theta. because the u is trying to go away. And what is omega? So the relative velocity is how much? U sin theta by r.
Yes.
But this will rotate, right? The line will turn by this angle. U sin theta by r, right? The value.
Yes.
Anyway, this is not required, but we can write. Okay. So we know the V approach. So the decrease in separation equals to V approach into time. So minus dr is V minus U cos theta whole into dt, and now we do into integration. And we are assuming V to be more than U. So when t is 0, the separation is L. When it is actually catching, the gap is 0. So L is equal to how much? And you can clearly see that we cannot integrate theta because theta is variable. Yes or no?
So we'll have to use the omega relation.
But still it is variable. I mean, we can't solve exactly.
Yes.
So once
R
we
is-
replace,
R is unknown.
yeah, R is unknown.
That's the biggest issue. Anyway, the whole idea is we cannot integrate. But nevertheless, what we know that the if I choose this distance as x, the x displacement is same for both, right?
Yes.
Yes.
X rat equals to x cat. And rat will be u into t. Cat will be v cos theta dt integration. Correct? Because v is constant, so we can say ut by v is cos theta dt. Now you can see we don't know the answer, but we know this answer. And you just need to substitute. So Vt minus u into Vt, sorry, ut by v. So after this much time it will catch. Okay. And what is the condition for catching? The v must be more than u.
You.
Okay. The last question from the same topic is same the rat and cat. So one is chasing. This is the chaser. So this is moving with velocity v. This is also chasing with v. Now what will happen? Is it possible to catch?
No, at infinity.
No, it will never catch because v it is equal.
Yeah, it's like
Because your distance, see, your speed is fixed. No? So by the time you travel this much and reach here, the same distance will be traveled by the cat. So cat will be somewhere here. No?
yes.
This length and this length must be equal, correct?
Yeah.
Same speed, same time, so same length, right?
Yes.
So when one is here, two will be here, right?
Yes.
And then this gap will be maintained throughout, correct? Isn't it? Because both are v, no? So the
The
gap will
gap-
remain constant. Tell me. Someone said something.
Yeah,
Can
not-
you repeat?
there's a gap will be constant.
See, the rat will never change the path. Who is chasing? One is chasing, no? So one
Yeah.
will eventually reach the top line.
This is like an asymptote. No, it will like
Yeah, yeah. So it is almost on that line. No?
it will never reach. No, at infinity only.
No, it is asymptote, but it is not becoming parallel. So physically it can catch on that line
Okay.
if we will speed up.
Okay.
So okay, so the idea is okay. Eventually, let's say at infinity, what will be the d?
0.
How it is possible to reach?
No, it
Oh
was
no,
like-
D will be very much more, right?
How much will be d? That's the question. At infinity.
Infinity.
So eventually it will become asymptote. So at infinity, it will be merging the line, correct?
Yeah.
But the gap will be there, na?
Okay. Yes. Yes. Yes.
Okay.
See, no matter what, can you change travel different distance?
No.
Your distance travel is same, no? So the curve length and the straight length, which one will be ahead at any time? The straight length will be
Straight
more,
path.
no? It will
Yeah.
be ahead of you, correct?
Yes.
So that is the question. Find the d at infinity or eventually. What is the with what gap they will move together? I mean, you understand what I'm saying. Okay. Anyone getting the answer? See, the method is same. You approach in the same fashion and write the kinematics. So first choose some random angle theta, write the equation. Okay, so you are failing to approach. I mean, it is like about approach only. A similar method will give you the same answer. The only difference is the distance of the rat will be d extra than cat in the x direction, right? So what we can write is minus dr will be v minus v cos theta, right? So when r is L, but eventually the r will be d, right? It won't be 0. And if you write the other equation, which is v p, the distance by the rat is d more than v cos theta dt, which means v minus v cos theta into dt is also d. So basically, this is d, this is d. So I can replace. So basically, what we get is that L minus d is d. That's it. Isn't it? So the final gap between the two will be L by 2, the half of the distance. At infinity, of course. Is this clear?
Sir, could you show the previous slide once?
See why I'm scared that you guys, when a new question comes, you fail to apply the approach itself. That is like concerning for me. If you know the answer, you will do it. If you don't know, then you will not even approach in right away. And JEE Advanced is all about, even if you come across a new problem, how you approach. I think that is most important part. One should learn the approach, the method of which is applied, the definition and so on. Now
Yes.
understood?
Try this again. Yes, sir.
Okay.
I'll try this doing only.
Try this again. Just what happened?
I was trying.
Okay.
Understood, sir. Got it.
What's the answer?
Yeah.
Okay. All right. So in the next lecture, what we're going to start is.
So here is the
So I'll mention the question number for the kinematics. So first is MCQ. Six, 7, 9. Those which can be asked in the JEE. That's it. Okay, that's it. How many questions? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So total 25 questions. So I think if you solve 5 questions each, then in 5 days you can finish. So don't solve at one go. Solve 5 every day. Okay.
Yes.
And then do your rest of your homework, like the rest of your practice from maths. And this time try to maintain a balance in all 3 subjects. Okay.
Okay, sure.
Yeah.
Okay, sir.
Okay. fine,
Next
take care.
Thursday lecture will be there, right?
Yeah, from next week it will be Thursday, not Friday.
Okay. Okay. Bye.
Sir, today do we have a lecture?
No.
Okay.
Acha. Ah,
That's
okay,
good.
bye.
Okay.
Bye.
Bye.
Bye, sir.